Yes, welcome back students. So in this video we are going to talk about the new concept called is quantum numbers. So these quantum numbers are the set of 4 numbers actually. So this set of 4 numbers will give you the complete information regarding an electron, regarding the size of an electron, regarding the orientation of an electron, and regarding its spin also. You get the complete information regarding the position, size, orientation and its spin. So you will get the complete information with the help of these 4 quantum numbers. So now let us check out that. Quantum numbers are, these are the set of 4 numbers. These are the set of 4 numbers which gives complete information. Regarding an electron, about the electron, we call it as quantum numbers, and generally we have 4 quantum numbers. The first one is principal quantum numbers. And it is represented by L. Okay, small m. And second one is we have azimuthal quantum number, and it is represented by the letter L. And we have third one is magnetic quantum number. And it is represented by small letter m. And fourth one we have the spin quantum number, and it is represented by small s. Okay, so see students, these are the 4 set of numbers. We discuss about this. What are the how do we get to know the information of an electron with the help of principal, azimuthal, magnetic and spin quantum numbers. So now these quantum numbers are the set of 4 numbers. Set of these 4 numbers which gives the complete information about an electron. So now let us look at the principal quantum number. Yes, students, now let us understand these 4 quantum numbers in deep. Okay, the first one is principal quantum number, and it is indicated by the letter n, small n. Okay, so this principal quantum number indicates the shell to which the electron belongs. For example, if you consider the basic structure of atom, for your understanding purpose, this is the nucleus we have. This is the nucleus, and this is where protons and neutrons are concentrated, and we have these energy levels. Okay, so this is not the actual structure, but for our understanding purpose of this quantum numbers, I am telling you this. Okay, so this is the nucleus, that is the center part of an atom where the protons and neutrons are available, and electrons will be revolving around the nucleus in this particular path called orbits. Okay, so this principal quantum number indicates the shell to which the electron belongs. Shell means these are the main energy levels, or we call it as main shells. Okay, so this is the first shell. So this is the second shell, this is the third shell, and it goes on. Okay, so this value we call it as N. Clear? So that is the principal quantum number that is indicated by N. If the value of N is 2, that means the electron that we are talking about is in the second shell. Clear? So we have given names for this also. For first shell, the name of the shell is K, and for the second it is L, and the third it is M, and the fourth it is N shell, and it goes on. But as per our elements is concerned, 118 elements, will be dealing with these 4 shells itself. Okay, so I'm not need to much study about the much 5th and 6th shell, that is not needed as per now. Yeah. So this value, that means the principal quantum number value, will give the information regarding the main shell. Okay, so now let's understand how many number of electrons that can be accommodated in a particular shell. Yes, okay students, so we are going for the first one, that is indicated by N. Okay, it means that if N equals 1, that is K shell, the first shell. Okay, if N equals 2, that is L shell, that is second shell. N equals 3, that is M shell, third shell. N equals 4, that is KLM shell, that is the 4th shell. These are the main energy levels, or the main shells that we are talking about. Okay, so coming to the accommodation of the electron in particular shell, we have a formula. It is 2n squared. 2n squared. That means that number of electrons can be accommodated in the first shell, second shell, third shell, and fourth shell. You know that n value is the principal quantum number, that is the number of shell. Okay, in the first shell, it is 2 into 1 square. That means maximum of 2 electrons can be accommodated. Okay, so in the second shell, it is 2 into 2 square, so it is maximum of 8 electrons can be accommodated. 2 square is 4, 4 into 2 is 8. And in the third shell, let's go for 2 into 3 square, so maximum of 18 electrons can be accommodated. You know that as we go farther from the nucleus, the size of the energy levels increases. As the size of the energy levels increases, that means size of main shells increases, more number of electrons can be accommodated. In azimuthal quantum number, we will get the information of subshells, or what we call it as orbitals. So till now, take this information. And next one we have in the 4th shell, 4 square is 16, 16 twos it is 32. 32. Okay, so these are the maximum number of electrons that can be accommodated. Okay, and this principal quantum number also gives the information regarding the size of the electron orbital. That means the main shell, what we have, the main shell orbital, so we get the size with the help of this principal quantum number. See, as the size increases, the accommodation of number of electrons increases. This is regarding the principal quantum number. Now let's go for the second one, that is azimuthal quantum numbers. This determines the angular momentum of the electron. Okay, so this determines the angular momentum of the electron, and it also determines the shape of the orbital. See, we have main shells, and later coming to the subshells. Okay, subshells are what we call it as orbitals. So generally we call them as subshells, but the key term is orbital. We get the information of this shape of the orbitals over here, and we have the formula for the particular value of n, that is for the particular value of the principal quantum number. The azimuthal quantum number values can range from 0 to n minus 1. 0 to n minus 1. Okay, this is the range of the value of L with respect to the principal quantum number, that is value of n. Okay. Now let's focus on that. So if the value of n is 1, it is L is 0 itself, because 1 minus 1, 0 to 1 minus 1 is 0 itself, so it is 0 itself. That means in case of the first shell, that is K shell, only one orbital is possible. Only one orbital is possible, that is we have S orbital. See, why you are writing the electronic configuration. See, while writing the main energy share, main energy levels, we do not mention it as KLMN. We will denote it by the value of N. See, it is 1, only one. Yes, 2 is possible. Because of this reason, no p orbital is obtained. You will understand this. And in the second one, when n equals 2, L can have values from 0 to 2 minus 1. That means 0 to 1. Okay, so it can have the value of 0 and 1. Okay, so the value, if the value of L is 0, it is the S orbital, and if the value of L is 1, it is P orbital. That means 2 orbitals are possible. That is S and P orbitals. In case of KL, for that reason only we have 2s2 and 2p6. We have S and P orbital. So now let's go for the third one. N equals 3. It is we have L value can range from 0, 1 and 2. That means 3 orbitals are possible. It is S, P and D. Okay. And in case of n equals 4, we have L 0, 1, 2 and 3. 4 orbitals are possible. So it is S, P, D and F. Clear, students? Don't get confused. In case of azimuthal quantum number, L value is 0 means it is S. It is S orbital. That means the subshell. And if L value is 1, it is P orbital. L value is 2, it is D orbital. L value is 3, it is F orbital. Clear? So you know how many number of electrons that can be accommodated in S, P, D and F orbital. Okay. In case of S orbital, we can have 2 electrons maximum. And in case of P orbital, we can have 6 electrons at the maximum. And in case of D orbitals, we have 10 electrons at the maximum. And in case of F orbital, we have 14 electrons at the maximum. So you can compare with the values of this also. Okay. So now this is regarding the azimuthal quantum number. This value of L gives the idea of the angular momentum of the electron, and also it determines the shape of the orbital. And third one, we have the magnetic quantum number. Magnetic quantum number, it gives the spatial orientation of the atomic orbital. Okay, so for a particular value of L, M can have the values from, I do not have any space to write here. Okay, let's have this later. Spin of an electron. Okay, I will write it here. Okay, so now in this case, for a particular value of M, particular value of M can have the values ranging from 2L plus 1 to L plus 1. Okay, so if L equals 0, M will be equal to 0 plus 1, it is 1. That means this value can have 0 also. That means only one orientation is possible for S orbital. L is equal to 0 means it is S orbital. So that means only one orientation is possible. Whereas in case of P orbital, it is L equals 1, M can have the values of 3. So that means it can have ranges from -1, 0 and +1. -1, 0 and +1. So it can have 3 variations, 3 orientations. And in case of D, it is L equals 2. M can have values of 5. There is -2, -1, 0, +1 and +2. So it can have 5 orientations. And in case of F, we have M value is 3 and M value is we have 7, it is minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. It can have 7 orientation. 7, okay. So this is regarding the magnetic quantum number, students. So you get the information regarding the spatial orientation. Now let's go for the last one, spin quantum number. So fourth one we have spin quantum number. It is represented by S. Okay. So this spin quantum number describes the spin of an electron. Spin of an electron on its own axis. Clear? So we have two values for this, plus half for clockwise rotation and minus half for anti-clockwise rotation. Clear, students? So this is regarding the information for the four quantum numbers: principal, azimuthal, magnetic, and spin quantum number.